All right, hello everybody. My name is Scott Atkinson, and I'm the spatial planner to the 6th National Report with the UN Development Programme, and I'm also the data manager for the UN Biodiversity Lab platform. I'm in lovely Brisbane, Australia here today, and we're going to have a quick presentation about data that exists on the UN Biodiversity Lab that relates to small island developing states. In this presentation, we're just going to talk about the UN Biodiversity Lab data that's available for small island developing states. I'm gonna break it down in the main issues involving SIDS in geospatial data into two categories. There are probably many more, and these two categories are rather coarse, but for simplicity, I'm just gonna stick with these for now. So I'm gonna look at these as both a lack of data coverage, as well as issues surrounding the spatial resolution of data itself. First is lack of coverage. Even where there's very high resolution data, there's often gaps in that coverage that occur across the world. And one particular area where this occurs quite readily is often in the Pacific. I'm showing you an example of data here. This is actually the global forest cover data. Some of you might be familiar with the Hansen dataset. And I'm looking at two countries that are actually relatively close to each other, neighbors within the Central Pacific. Here on the left, we have Fiji. Fiji is showing a very good cover from the global forest cover data. Just a reminder, this data does have a 30-meter resolution globally. While Samoa, which is just on the other side of the antimeridian, or the international dateline, doesn't have any coverage. Similarly, many other islands in the Pacific that are just to the east of the 180-degree meridian just don't have global forest cover data at all. It's really only until you get to Hawaii that you again have global forest cover data in this region. So if you notice, you look at Fiji and you see there's coverage of not just the main islands, Viti and Vanuatu, but also some of the smaller islands, Levuka and Kadavu, for example. And it's worth noting that both of these are smaller than, for example, Upalu or Savaii in Samoa, yet they do have coverage of the global forest cover data. So there doesn't really seem to be any rhyme or reason to this, and I have yet to find an explanation for it myself. But it just is meant to really highlight the fact that even within regions in the world, there are gaps in coverage that don't really make sense sometimes. Next, we're going to look at spatial resolution of data. So just because data covers an area doesn't really mean that that data is going to be of much use to some small island, for example. Here we're looking at Sao Tome and Principe and looking at some data of derived species richness metrics. On the left panel we have species richness, and on the right we have rarity weighted richness. And if you look very closely at those maps, you see there's exactly 8 pixels in the country. So that's not very great. That doesn't really help inform much of anything. You can see obviously rarity weighted richness has a much deeper red, which indicates that that those cells are actually quite important. But that's something you would expect in a lot of island nations due to the high level of endemism that we see on islands. So while this data is derived from the IUCN, and there is some currently active work on producing datasets that are higher resolution aggregates of this. Currently on UN Biodiversity Lab, the data we have is quite coarse, although I will again note that there is some works coming in the pipeline that we hope to have available soon that should drastically reduce this. And again, as well, looking at spatial data resolution and noting again, just because data covers an area doesn't mean it's necessarily going to be of much use in a SIDS nation. We can also look sometimes at how poorly the data actually matches shorelines. So on some small islands, these mapping errors can lead to quite significant errors when calculating areas of features, as well as the intersection of these features with, for example, protected area boundaries. Protected area boundaries are often legally defined, so they're generally very high resolution. But they don't necessarily then talk well with other datasets, for example, ecoregions or sometimes even KBAs. And it's important to note that sometimes these data sets that aren't very well aligned with actual shorelines of small countries are sometimes used in official reporting to international agreements. So in the slide you see, in the map you see, this is looking at Cabo Verde, and we are looking at the ecoregions data. And if you look close enough, you can see that there's two issues. First of all, there really isn't fine enough resolution in the ecoregions data to probably do justice to the types of habitats that exist, or the types of environments that exist in the islands. And you can kind of see that in the fact that there's really only one ecoregion in the entire country. And similarly, if you look at the polygons of those islands, you can see that there's significant shoreline errors. As I'd mentioned, that can lead to significant errors in geospatial analyses. So next, we're just going to look at some of the data available on UN Biodiversity Labs for two SIDS. We're going to look at the Comoros Islands and Trinidad and Tobago, just to kind of see how some of the data we have pertains to countries. So first of all, in Comoros, we're just going to look at the protected areas data. This is coming from the World Database on Protected Areas, and as I just mentioned, this is the legally defined boundaries of protected areas in the country. So this is provided by the government to the WDPA, and so these are generally fairly high quality polygon data sets that are provided. So this is pretty much as good as it generally gets in terms of protected areas. And because these are polygons, they're as high resolution as they are mapped. Go on to some other data sets, we can look at species richness. So, for example, in the map you see here, the yellow to dark red hues are terrestrial threatened species richness, and those that are in the blues to purples are marine species richness, coming from the AquaMaps database. And the things that stand out are that in both cases, the resolution of the data, particularly relative to the size of the islands, is really quite coarse. And so we might ask ourselves, is this at all helpful? We can look at some of the islands here. We can see that there's, for example, 2 pixels that represent threatened species richness on the island, or 3 pixels, or 4 pixels. Is that really helpful? In the marine realm, the data is also even coarser, but that's generally to be expected in the marine realm, simply because the marine realm is a much more difficult realm to map, and there's a much more fluid motion, not to make a horrible pun. So that's almost potentially to be expected. But we can still ask ourselves, are these actually helpful and for our purposes? And I'll make one note as well, we're looking at the threatened species richness, terrestrial threatened species richness. This data is coming from the IUCN, and there are some data sets at a much higher resolution that are currently in process of being made, but they're not yet available. So we do hope to have these available soon. Looking on next in the Comoros, we're looking at both ecoregions and marine ecoregions, and we can see that in the Comoros, the data is relatively precise. That means it doesn't have really the severe shoreline issues as I pointed out previously, but it still only includes single regions for both data sets. So we can again ask ourselves, is this really helpful? I guess my own perspective is it's not really all that useful, particularly on the terrestrial side of things. Marine realms might be fine for the reasons I mentioned before, but there's surely much better maps to approximate habitat types across the islands. Next, we're going to look at livestock density data from the FAO. So this appears to be a fairly high resolution, and it does tend to cover the islands quite well. And while I'm not a specialist in agronomy or anything of that sort, I reckon it to be a fairly decent data set to use in lieu of any higher resolution national data that may or may not be available. And finally, in Comoros, we're going to look at the global forest cover data, which shows the forest cover as the percent of canopy cover, as well as I'm showing here the year of loss between 2000 and 2018. And we can see that the data covers the islands pretty completely. It's very well matched to the islands. this is derived from Landsat data, so it's a approximately 30 megapixel resolution, and it's generally considered to be a pretty solid, robust data set, and it's regularly updated. And as I mentioned, it fully covers the islands. So this would be a very appropriate data set to use potentially for mapping forest cover change on islands over time. So now let's move over to the southeastern Caribbean, and here we're looking at the protected areas data for Trinidad and Tobago. And similar to the Comoros, this is about as good as it gets. These are the legally defined boundaries of protected areas as provided to the WDPA. So you probably can't expect too much more. This is what you're going to find coming from governments as well. And again, if we look at species richness and TNT, again, the yellow to dark red hues are the threatened terrestrial species richness, and the blues to light purples are marine species richness. The things that stand out again are in both cases the resolution of the data, particularly relative to the size of the islands, might be a little bit better than it was in the Comoros, but it's still relatively coarse. It's still quite coarse. And so we can ask ourselves, is this actually helpful for our purposes? And you might as well make note of the fact that Tobago itself, most of Tobago, doesn't actually have any terrestrial cover. There's 2 pixels up there representing it. And it's worth noting again that there are some data sets coming down the pipeline that should be available soon that are at much higher resolution. So this situation will probably improve in a short amount of time. So if we're looking again at Trinidad and Tobago, looking at ecoregions, that's the land, and marine ecoregions, we can see that in TNT we don't really have the severe shoreline issues that I had pointed out previously, and now there is some differentiation, and we have 3 terrestrial ecoregions in the country, but still a single marine ecoregion. So we can justifiably ask ourselves if that's helpful and sufficient. I think on the terrestrial side, it's certainly better. It does capture mangroves and some of the variation between different habitat types and different ecoregions within Trinidad and Tobago, as well as the marine regions might be fine, but potentially there's going to be some national data to better approximate habitat type across the islands that would be much more useful. Here we're looking at livestock density again from the FAO on Trinidad and Tobago, and as previously mentioned, this is pretty high resolution data and covers the islands well. So in lieu of having higher resolution national data, this is probably a fairly safe data set to use for these purposes. And just as a side joke, it doesn't really tell me where I can go and get the best roti on the island, which is kind of important when thinking about Trinidad and Tobago. And finally, we're going to just look at forest cover data on Trinidad and Tobago, and this is again the global forest cover data. It shows the forest cover as the percent canopy closure as well as the year of loss between 2000 and 2018. This is again 30 megapixel resolution derived from Landsat satellite data. And as we can see, it covers the islands pretty completely. This is a data set that's regularly updated and is generally considered to be a pretty solid data set to use. So just to quickly go review what we've kind of gone on, some of the key points I hoped to have made. Global data often does exist, even in small island developing states. But so do gaps. There are often regional gaps, and there are even intra-regional gaps in data. So sometimes even neighboring islands, for example, one island might have high quality data and the other has nothing at all. So there really is no one-size-all-fits approach. Also, shoreline issues can be a significant problem, even with high-resolution data, and this can lead to significant errors in geospatial analyses. And these issues are particularly magnified in the impact that they have and the effect they have by small islands themselves. And it's also worth repeating again that the global shorelines used in many global datasets are not consistent, and that in itself again leads to incorrect boundaries in data. So this leads to all kinds of errors, particularly with small islands. For example, we know, as I pointed out, the ecoregions data almost never lines up exactly with island shorelines. And the small nature of islands just simply magnifies the effects of incorrect boundaries on geospatial calculations. And I'll point out again that new data is going to soon be available on some of the species richness metrics at a much improved resolution, and we hope to have that available for people soon. So I'll stop there. If there's any comments or questions, thanks for listening. You can email me there at the email address listed, or also at support@unbiodiversitylab.org. Many thanks.